respiratory system is specifically designed to allow our bodies to exchange oxygen and CO2 with the outside world, and also supplies the airflow for producing a source for speech production. Within the bony structure of the thoracic cavity are two specialized organs known as the lungs. In this video tutorial, you will learn about the lungs themselves, as well as label the passageways through which air travels as it enters and exits the lungs. The lungs are made of specialized tissue designed for exchanging oxygen and CO2 with the outside world. Within the bony structure of the thoracic cavity are two lungs, one on the left side and one on the right side. Let's explore the anatomy of these two specialized structures. The top of the lungs is called the apex. Remember that the rib cage is narrow at the top of its barrel-like shape, so the apex is a small pointy area. The bottom of the lungs are called the base. The base of the lungs rests on top of the diaphragm muscle, which was that large dome or parachute-shaped muscle that separated the thoracic cavity above from the abdominal cavity below. We can label two other surfaces of the three-dimensional lungs. The outer surface of the lungs is referred to either as the superficial surface, meaning toward the body surface, or the costal surface, meaning ribs. The superficial or costal surface of the lungs touches the inside of the rib cage. Deep between the two lungs is the deep or mediastinal surface. Mediastinal refers to the area between the lungs, which includes organs such as the heart, esophagus, aorta, and various glands. Each of the two lungs is separated into different lobes. This is a nice design feature because disease of one lobe does not spread as easily to other lobes, and also provides backup in cases of punctured lobes. Each lobe is a separate and independent section of lung tissue. The right lung is the larger of the two and contains three lobes: the superior, middle, and inferior lobes. The left lung is smaller and contains two lobes, a superior and an inferior. Why might the left lung be smaller? What else sits just to the left of midline within the thoracic cavity? By the way, what did we call the top point part of the lung? What did we call the outer surface of the lung? Notice the imprint of the ribs in these fully inflated lungs. Each lung is coated with a special lining called the pleural lining. Please note the spelling of plural with an EU. There is a single pleura, or there are two more pleurae. There are two layers to the pleural membranes. The visceral or pulmonary pleura cover the surface of the lungs themselves. The parietal pleura covers the inside of the rib cage. Each of these membranes produces a thick, sticky fluid. Normally, these two membranes are in contact with each other, which helps to adhere them together. Think of it as two pieces of plastic wrap with a few drops of water between them. The two pieces of plastic wrap will adhere to each other with an airtight seal between them. Here's a picture to help describe the two pleural membranes. Between the visceral pleura on the lungs and the parietal pleura on the inside of the rib cage, then, is a fluid-filled airtight area called the pleural cavity or the pleural space. It is the bond between these two pleural membranes that keeps the lungs expanded within the inside of the rib cage. If anything were to puncture this space and cause air to enter the airtight pleural space, the seal would be broken. When this happens, a person experiences a collapsed lung. You should also take a moment to check out the tutorial on this animated web link. So, we have two lungs. How do you get air in and out of your lungs? That's where the passageways come into play. The three main functions of these passageways are to conduct airflow into the lungs for gas exchange, filter the incoming air, and expel contaminants, such as dirt, dust, particles, smoke soot, or mucus. As we enter the lower respiratory tract, air passes through the larynx, or voice box, then enters the trachea, or our main air pipe. The trachea splits into two main bronchi, then continues to further subdivide until it reaches terminal bronchioles. The terminal bronchioles lead to smaller alveolar ducts, which lead to clusters of air sacs, also known as alveoli. Remember that it is the individual tiny air sacs that are surrounded by capillaries to allow for gas exchange to occur. The trachea is the largest tube of the lower respiratory system. It is about 11 centimeters, or 4.5 inches long, and about 1 inch in diameter. It is located just below the larynx. At the bottom, the trachea bifurcates, or splits into two, at a point known as the carina. The trachea is lined with epithelial tissue that contains specialized cells called cilia. Cilia contain little hair-like projections that help to sweep mucus and contaminants up and out of the lower respiratory tract for removal. It is important that the trachea does not collapse and close the airway. This structure is provided by the 16 to 20 C-shaped cartilaginous rings that are stacked vertically to form the tube. The C-shaped cartilages protect the anterior or front of the trachea, but are open posteriorly. The trachealis muscle connects the two open ends of the C-shaped cartilage in the back. When the trachealis muscle contracts, it will narrow the airway by bringing the open ends of this C-shaped cartilage together. This design provides structure, yet flexibility, in the trachea. Just posterior to the trachea, or behind the trachealis muscle, is the esophagus, or our food pipe. There is just a thin layer of epithelial tissue and muscle that separates the trachea anteriorly from the esophagus posteriorly. Below the trachea are the two main bronchi. Each bronchus enters one of the lungs and then further subdivides within each lung lobe. Notice that there are differences between the left and right main bronchi. As the trachea bifurcates at the carina, it takes a sharper angle to head toward the left lung, about 50 degrees from midline, while the passage into the right lung is less steep and more gradual, about 25 degrees from midline. This will be important when we discuss swallowing physiology. If you aspirate on something and it enters your lower airways, into which lung will it fall and settle most easily? If you answered right, then you're right. As the airway passages continue to branch, they become progressively smaller and narrower. In addition, as the air passages get smaller, they also start to contain less cartilage for structural support while containing more smooth muscle. Clinically, this means that it will be easier for these smaller airways to collapse because they do not contain cartilage to keep them open. This is exactly what happens in emphysema, where the smaller airways collapse and trap air in the lungs. As the air passageways become increasingly smaller, we change anatomical names as we go from the bronchioles to terminal bronchioles at the end of our journey. Alveolar ducts, think of air moving through your house in the air conditioning ducts, and finally, to the alveoli. All the way at the end of our journey into your lungs are the tiny specialized air sacs called alveoli. The singular is alveolus. Each alveolus is surrounded by capillaries and is the location where gas exchange occurs. Human adults have about 300 million alveoli in our lungs, which if flattened out would cover the floor of a 10 by 24 foot room, or about 240 square feet, slightly larger than Dr. Lemoncello's office. The advantage of the spherical arrangement of these air sacs is to increase the surface area for gas exchange within the lungs. I think this design has succeeded. This concludes this tutorial and the tutorials for week 2. Please pause the video to practice applying your knowledge of these structures.